Hey guys, this is Mr. Sal. We're going to look at applications of exponential functions, so exponents with word problems. Thanks for watching. Don't forget to like, comment, and subscribe. All right, 6.2. When solving word problems, read the problem. Sometimes that's our first mistake. I do it often, actually. I just kind of look at the numbers and calculate stuff, and then when I go back to make sure I did it right, I read it or did it wrong because I didn't read it correctly. Sometimes you have to reread it, and that's okay. Just know what you're solving for and what they're asking so that we know how to solve it too. So, are we comparing time, rate, distance, part of a job, stuff like that? Translate the information into an equation, solve, express the answer in context of the problem. So, we're just kind of saying to label the answer on that last part. Find the amount of money in an account, if $9,400 is deposited at 5% interest compounded annually, and the money is left for 7 years. Round answer to the nearest 2 decimal places. We definitely need a calculator on this one because we're going to use multiplication of that percentage right there. And I'm going to do this a long way, and hopefully that will reveal a short way to do it. Okay? So here's what we know is we're going to start out with $9,400. We're going to call this year 1. So we're starting with $9,400, and we're going to make 5% interest. All right. So I need to multiply that by 5%, which would be 0.05. And when I solve this, it's going to tell me how much I made in interest for that 1 year. $8. So after 1 year, you made $470, but you have that additional principal that you put in, the $9,400. So after 1 year, with interest, you have $9,870. That's a very nice sum. Well, let's look at year 2 because we got 7 of these suckers. So year 2, we're not starting with $9,400. We're starting with what we ended year 1 with, which was $9,870. And the process repeats. We're going to multiply that by our 5%. So that's an additional $493.50, which we need to add to the value we started with. All right, now, I think even in this class, but in 950 we learned that we don't have to take that 5% and add whatever that value is. What we can do, and we'll do it for year 3, which is just going to slightly speed up the process. We know we're going to start where we started year 3 with the $10,363.50. But we're not going to look at this as 5% anymore because you keep the 100% of what you start with, okay? But then you're adding 5%, so we can kind of wrap this up into one calculation by making this 105%. What we did before, right, is we took the 5%. Let's look at year 1, right? We took 5% of the $9,400, and we got $470. Then we added, well, that was what we started with. Well, what percentage of what we started with is that? The 100%, right? We started with 100% of $9,400. But then we added 5% to that, which was the 470. So instead of making it 5%, then add it to the total, we can just make it 105%, multiply it, and that would give us the answer. So that is rounded. So yeah, this 1.05 represents 105% of what we started with, because you're always adding the 5% on that business right there. We're almost halfway there because we got year 4 now. So we're going to start with our $10,881.68. And I'm going to multiply that by 1.05, which will tell me how much money we would have after year 4. All right. Well, that is year 4. Let's look at year 5 then. And we are going to start with that $11,425. 76 cents multiplied by 105%. And that equals, well, that's year 5. Let's look at year 6 then. Starting in year 6 with $11,997.05 multiplied by 105%. $12,596.90. And then finally, year 7, we're going to start with that $12,596.90 multiplied by 105%. And we get $13,226.70, rounded 75 cents. All right. Now, if you're still awake after all that, right, because that was a lot of fun. We do notice a pattern, though, right? What is it that we kept multiplying by on that stuff? So, does anyone remember what we do with repeated multiplication? How do we simplify it? Exponents. So, here's what we could have done. And you guys are going to hate this. Well, you'll hate me, but you'll like the method, hopefully. Actually, you still may hate both. You started with $9,400, right? And if we looked at that first year, we would have multiplied it by 1.05. And that would have been the first year, right? And then we would have multiplied that by 1.05 for the second year. And then we would have multiplied that by 1.05 for the third year, and so forth. You guys remember how math people are kind of lazy? We hate to write the stuff over and over. Well, that's why, like you guys said, we have a way to simplify this by using exponents. So I have 1.05. How many times did we multiply that by 1.05?
7 times.
7 times, which was how many years, right? And if you put this into the calculator, you'll get the answer on that. Actually, for my calculator, this one came out as $13,226, and rounded it would be 74 cents. Just know either way that you do it, I'm okay with it. It's off by a penny. That's because of all the rounding we did in the 7 sets, and this one is kind of just all. Well, there's no rounding, except in the end. Well, this does give us a formula, by the way. And I should emphasize this a little bit more, but this is compounded annually, right? So at the end of year, it was receive the interest, and then it starts over for the next year with that new amount. And that's how we get compound interest on this stuff. You take the principal and you multiply it by the percentage. Well, you always start with 100%, and then you add whatever the rate is as a percent, well, decimal. So they use R for rate. Sorry, my lowercase r's aren't very good. And then we take that to the power of time in years, and that would tell you how much, well, I guess total money you would get. I'll just put I for interest. But it's more than interest. It not only tells you the interest, but how much total you would have at the end there, okay? Again, I'm not sure if they give this to you on the final or not. I'm sure we'll know when we do the review, though. And to be honest, I have no intention to use that first method ever again. Unless for some reason you guys are like, yeah, no, I have to see it. Okay, then we would, okay? But otherwise, I have no intention to use it. So on this one, you deposit $5,000 into an account earning 4% interest compounded annually. How much will you have in the account after 15 years? Oh, okay. Well, how much are we starting with? $5,000. And then I'm going to multiply this by, again, you're going to start with 100% of 5,000. That hopefully makes sense. But we're going to add 4%, which as a decimal, because that's our rate, is 0.04. So 0.04 added to the 1 for how many years? 15 years. So that's our exponent, because it would just keep repeating that 15 times. And you could type this into the calculator. You could solve it piecewise, I guess. 1.04 to the power of 15 right there, multiplied by 5,000. In any case, all right, this is what my calculator tells me. $9,004 and rounding 72 cents. That's 15 years of compounded interest. I don't want you to answer this question, but just think if that's a good investment or not. You can decide. This is a nice one. Because, on the homework, if we see you didn't do it, it just means you quit. It's not really as bad as it looks, by the way. And it does have two parts, right, the A and B. Let's read it. A bank features a savings account that has an annual percentage rate of 2.6% with an interest compounded semi-annually. Zach deposits $11,500 into the account. The account balance can be modeled by the exponential formula, that stuff. The rest of it just defines what that stuff is, okay? So S is the future value, or S of t. P is the principal, or the present value. R is your rate. N is how many times each year that the interest is compounded, which in this case, how many times is it going to be compounded every year if it's semi-annually? Yeah, twice. So N is 2 for us. And T is the actual number of years, which in this case, that we won't know until we get to B on that stuff, okay? So for part A, it just wants us to define those values. So our principal, or starting value, principal is how much Zach deposits, which is $11,500. And then the R is the rate, which is the percentage that they give us. They've already told us what R is. At 2.6%, we don't want the percentage though, we want the decimal value on that, so 0.026. And then it wanted an N, which we already said was 2. Because it is going to compound 2 times every year, which is, again, semi-annually. So that answers part A. Part B, how much money will Zach have in the account in 7 years? So it's really asking us to solve for S of 7 on this one. I'll change the color on that. So it was S of t, and t now is 7. So just writing this out, the formula, and I kind of spaced that out on purpose. So my principal is $11,500. The rate is 0.026. 0.26. Then we got 2 N's to replace on this one. 2 and 2. And then, of course, our time, which is 7. Oh, that's 2 times 7, by the way. And you could type this into the calculator, exactly like we see it right there. Now, in any case, I mean, you could simplify it by using the order of operations. I'm just going to use the calculator because it's, well, we want you to. And if you do, you may want to put that in parentheses, just so it knows that it's the exponent of 2 times 7. Or just change it to 14, either way. All right, so after 7 years, Zach, assuming he didn't touch the money, would have $13,779.39. Bam. So again, be careful. I mean, it looks worse than I think it is, because they told us all the values. We just got to plug it into the calculator. It's more wordy, perhaps, than it needs to be, though. You can decide. The value of a car is how much the car is worth. The equation below models the value of a car purchased for $11,000 over time. V, which I assume is the future value, equals, that should be like v sub 0, like this, to show like an initial value. And then in parentheses, 1 minus 0.19 to the power of t. Just looking at this, does anyone know why it's subtracting the 0.19? Yeah, so it loses value. It loses value through depreciation. What percent or what rate is it depreciating at? So since it's subtracting 0.19, we'll change that into a percentage, which is the rate. So it's depreciating at 19% every year. I don't know how realistic that is. Sorry, but whatever. How much is the car changing in? Oh, I thought it wanted us to calculate a value. 19% on this one. That's it. I kind of want to say it decreases by 19% just to be more specifically. I mean, you could just say negative 19%, but it's changing in value 19%. That works. All right, this one's more like the problem I was thinking of solving. A car purchased for $16,000 depreciates at a constant rate of 17.5%. What will be the value in 5 years? Round answer to the nearest 2 decimal places. So let's just consider this in, I guess, realistic terms, or, I don't know, more foundational terms, right? We're going to start with our $16,000 car. And it's going to depreciate at 17.5%. So I'm going to multiply that by percent, just like we were with the compound interest. You're going to start with 100%. Now, if you like to see that as 1.00 as 100%, that's fine. This one's depreciating, though, which means we're going to subtract it at 17.5%. Well, 17.5% would be 0.175. So we'll write that in. And how many times would we repeat this multiplication? It's for 5 years, so it's a power of 5 on that. Now we could plug this into the calculator directly, or you may see that it would be at each year, it would be 82.5% of what it was before. But again, that's going to be, oh, I wrote that wrong. 82.5, there we go. Multiplied by the 1600. No, it doesn't matter again which way you do it. It's going to give you the same answer either way. All right, so there's my answer. And that is rounded, $6,114.91 after 5 years.